Today's lesson is on related rates. The handout we're using is Exploration 10.4, Introduction to Related Rates. In this situation, we have a real situation I'm going to read. Phoebe is going east on Alamo Street at 40 feet per second. So Phoebe is traveling east, that's the direction she's going, and her rate of change or speed is 40 feet per second. Meanwhile, we have Calvin, and Calvin is heading south. So that's why this arrow is right here indicating Calvin is going south. And his speed is 30 feet per second. So Phoebe wants to find out whether the straight line distance between them is increasing or decreasing. Now the straight line distance between them is labeled in the picture as z, and it's this distance right here. So the question is that length increasing or decreasing? So we're going to go ahead and answer the questions on this handout so that we can answer Phoebe's question. So let x be Phoebe's distance from the intersection. So my intersection is this big red dot, and the distance away that Phoebe is x. So I've labeled that in my picture. That's that red distance. And y is Calvin's distance away from the intersection, and that's right here in blue. That's Calvin's distance away. So write the rates that you know and explain why dy dt is negative. Rates. Okay, so we're talking about rates. And it says down here that we know dx dt. Well, let's see. What is dx dt? That is the rate of change of x with respect to time. So let's think about what x represents. X represents the distance that Phoebe is away from the intersection. So that's a length, that's a feet. And so a rate of change of x with respect to time would be the change in feet over time, which would really be a speed. So we do actually know dx dt, and that speed is 40. We really should write the units there, but I didn't leave you enough room, so I'm going to write my units right below. But I should always write my units whenever I write a rate of change. Next one we have is dy dt. Now dy dt is the rate of change of Calvin's distance over time, and we have his speed, and his speed was 30 feet per second. However, we have a little hint right here. Explain why dy dt is negative. And why is dy dt negative? Well, Calvin is traveling south, which means this distance is getting smaller and smaller and smaller. So his rate of change is actually negative because as he moves closer to the intersection, the distance he is away is getting smaller. Moving on to number 2. Let z be the straight line distance between Calvin and Phoebe. So I've indicated that in black. Write the symbol for the rate that you want. Well, what I want is the rate of change of that straight line distance with respect to time. So that will be dz dt. To find the rate you want, you need an equation relating the variables in the known and wanted rates. What the heck? Write an equation relating x, y, and z. Okay, that's actually what I want to do. Write an equation that relates x, y, and z. So I look back at my picture. Go back to your picture. Now in this picture I have a triangle. And in this triangle I actually have a right angle that I didn't put in here, but I know is there if I have an intersection like this. So there's my right angle. Now I know I'm dealing with a right triangle, and in every single right triangle we can use Pythagorean theorem, and I'm going to write that as the relationship between x, y, and z. So I'm going to have x squared plus y squared will equal z squared, and again I'm just using Pythagorean theorem based on the picture. I'm in a right triangle. Step 4, I want to differentiate both sides of the equation in problem 3 implicitly with respect to t. So what that tells me I'm doing is I am taking d dt of x squared, I'm taking d dt of y squared, and that's equal to d dt of z squared, which means I'm going to have chain rules everywhere. So when I take the derivative of x squared with respect to t, that derivative is 2 x and then times the derivative of x with respect to time. Normally, when I'm taking a derivative implicitly, I'm taking the derivative with respect to x. And this term, when I take the derivative of x, would be dx dx, and I usually don't even write it down because it's a 1. However, I need to pay attention that I am taking the derivative with respect to time. So this one, with my y squared, I'm going to have 2y dy dt equals, and z will be 2z, and then the times the derivative of z with respect to time. So we have this right here. It does say to solve the resulting equation for dz dt, and I can do that if I want to, or I can leave it alone just the way it is. I'm going to work with it just the way it is. However, if you do go ahead and solve for dz dt, then you're going to get x dx dt plus y dy dt all over z. And if you want to work with that for the next part of the problem, you are welcome to work with that. Moving on to question 5. When Phoebe is 200 feet from the intersection, Calvin is 600 feet from the intersection, and at this time is the straight line distance between them increasing or decreasing, and at what rate? I recommend you do this somewhere other than this space. I did not give you enough room in the space for number 5 to solve this problem. So if you have another piece of paper, you might want to do it on there, or you can just flip your paper and do it on the back. I will also say this, problem number 7, we're going to end up doing on the back because again, it didn't fit in this space. So however you want to allocate your space, number 5, we probably want to do on the back. So I'm going to get myself a new screen. So in number 5, what I know is that I have x is 200 and I have y is 600. So x is Phoebe's distance from the intersection, y is Calvin's distance from the intersection. And at this time is the straight line distance between them increasing or decreasing, and at what rate? I'm going to write down the other rates that I had. From the front, I knew that dx dt was 40 feet per second, and I knew that dy dt was negative 30 feet per second, and I need to find dx dt. I'm also going to write down my derivative that I had found from the front, 2x dx dt plus 2y dy dt is equal to 2z dz dt. Now over here, I'm going to draw myself a right triangle, because what I need to do first is I need to go through and kind of do a checklist for this equation with my derivative. And do I have everything that I need? Well, 2 is a 2. That's fine. X. Do I know what x is? I do know what x is. X is 200, so I've got x. I need a dx dt to be able to plug in. Do I have a dx dt? I do. That's 40 feet per second. 2 stays 2. Y. I need a y to plug in, and I know that y is 600, so I do have that. dy dt is the next thing I will need to plug in, and I do have that. That's negative 30 feet per second. Check that one off. The 2 stays. The z, I don't have a z anywhere. And the dz dt, well, this is what I'm trying to find. So that's obviously going to stay dz dt. However, I need to find out what z is. However, I was given some information. So at the instant that I have that my y is 600, I know that my x is 200, and then my z is going to be whatever this is right here. So technically, I can actually find z at the moment where x is 200 and y is 600. And I'm going to do that with Pythagorean theorem. So I have z squared is equal to 600 squared plus 200 squared. And I'm going to work this out. So as I work this out, I get z squared is equal to 400,000. And then to get z, I'm going to take the square root of that. And for right now, I'm going to leave it just like that. I don't really want the decimal version because then I'm going to have to plug that entire thing into my calculator. and I really don't want to do that if I don't have to. So at this point, I go back to my equation. I have a z. I can check that off, which means all I need to do is plug everything in and then get dz dt by itself. So if you use the other equation where you already got dz dt by itself, plug everything into that and it'll be much more simple to work with. So at this point, let me start plugging things in. So I have a 2 times my x, and my x is 200. And then I have a dx dt, which is 40. And then I'm going to add 2 times my y. My y at this point is 600. And then times dy dt, which was negative 30. And that is equal to 2 times the square root of 400,000. Sorry, times dz dt. Oops, I want to make that green. Times dz dt. I apologize, I went over here in my other work. So I'm just going to simplify everything and see what I have here. And I get 1,600 plus a negative 36,000 equals 2 times the square root of 400,000 times dz dt. I'm going to combine my like terms, and this gives me negative 17,200 when I combine and divide by 2. And that's equal to 400,000 times dz dt. And then I'm going to divide by the 400,000. And when I do that, I get negative 27.1955 feet per second. I'm going to throw my units on there. And that is going to be my dz dt. Okay, so at this point I've done all the math. I've got all my math, my calculations are all here, everything's fabulous. Now I need to go back and read the question and answer the question in English in a sentence. Now in question 5, we were given a question in English. At this time, is the straight line distance between them increasing or decreasing? At what rate? I need to answer that question in a sentence. So to answer that question in a sentence, I would say the straight line distance is, and right now, is my rate of change telling me that that distance is increasing or is it decreasing? Well, my rate of change is negative, which means my straight line distance is decreasing. Now I need to be careful about how I say at what rate. At, here's my rate. If I put in a negative 27 right now, then I say the straight line distance is decreasing at negative 27.1955 feet per second. And if something is decreasing at a negative rate, that really means it's increasing. So I need to say the straight line distance is decreasing at 27.1955 feet per second. So I've got number 5. Moving back to the front, I'm now looking at number 6. Naive thinking might lead you to conclude that since Phoebe is going faster away from the intersection than Calvin is going toward the intersection, that the distance between them is increasing. And do your calculations confirm or refute this conclusion? And our rate of change was negative, so that actually refutes it. Even though it seems like z should be increasing at that moment, at that particular moment, z is actually decreasing. That doesn't mean that z is always decreasing. It just means when x is 200 and y is 600, we do have that situation. So number 7, we are going to now write a list of the things you did to solve this related rates problem. And I would suggest you write this on the back. I could not get it to all fit on the front. So for number 7, this is what we're going to do for all related rates problems. So you are writing your step-by-step direction for every related rate problem that you do. The first thing that we really need to do is actually provided with us, and that is to have a picture. And again, we had a picture in this one, but if you don't, it's very, very important that you draw yourself a picture to start off. That's going to give you the relationships that you need. The next thing that we need to do, that we actually had done for us again, was label the picture with the rates that you know. Now, that's not talking about when x was 200 and y was 600. This is about the actual rates that you know. So those speeds. The next thing that we need to do is write down the rates that we know. And when we write down those rates that we know, we're going to write them mathematically. Meaning we knew we were talking about speed, but when we wrote them down, we wrote them as a rate of change. Mathematically, I can't spell, sorry. So what we did in ours is we wrote dx dt is equal to 40 feet per second. So that's what I mean by mathematically. Step 4, we need to write down what we need to find, and we're going to do that mathematically as well. So write down what you're trying to find. And again, we want that mathematically. That's any. And we did that where we said, okay, what we want to find is dz dt. Next step, we need to find the relationship between our variables. So we need to find the relationship between our variables and our variables were x and y and z were our variables. And for us, the relationship was the fact that we were in a right triangle, again, going back to the picture being so important. And our relationship ended up being Pythagorean theorem, x squared plus y squared is equal to z squared. That was our relationship. Number 6, once we've got this relationship, we're going to take the derivative of this with respect to time. And we're going to take this derivative implicitly. So we're taking the derivative implicitly with respect to time. So we're basically going to do d dt of the x squared plus y squared and the d dt of z squared. And again, we're doing that implicitly. Moving down, step 7. We're going to use any given constants to find any missing constants. So we did a little check, and we knew we didn't have a z. So what we did is, well, we knew we had x and we knew we had y, and we had to find z. And again, we're using that relationship again. So again, this was, for us, we used x was 200 and y was 600 to find z, and we use x squared plus y squared is equal to z squared. Next, we plugged everything in. So we plug in all the known values. So our variables and our rates, and solve for what you want. I'm gonna squeeze that right there, sorry. Okay, so we just plug everything in and we solve for what we want. And finally, step 9 is our last step, and that's your sentence. So write a sentence answering the question. So that really involves rereading the question. I'm going to write that in there. Reread the question. And that is how you are going to solve all of your related rate problems that we are going to do in calculus. So I hope this was helpful. Bring this to class so we can work some in class, and have a very wonderful evening.